This is the second lecture in the series of continuation from offline lectures about complexity. We'll start straight away from the point at which we stopped in the last class. So we would be giving a reduction from CNF SAT to click. As both these problems have been discussed in classes, I won't spend much time on them. To quickly review them, CNF SAT problem or language goes as follows. We are given a set of n literals L1 to L2 and a Boolean formula F. The Boolean formula F is in CNF form, that is the conjunctive normal form or and of ORs form. And the length of the formula is of the order of n raised to constant. And what we have to find or what we have to determine is whether this input belongs to CNF SAT or not, which means is there an assignment of zeros and ones to L1 to Ln such that the formula F becomes 1. We have also studied about the click problem. We are given a graph and a positive integer k, and we want to find out or we want to know whether there is a complete subgraph G dash with k vertices or more. That is a fully connected, completely connected part of the main graph of size at least k. So both these problems were discussed in class. So we can proceed from there. So let me move ahead. So how do we go ahead with this reduction? We know what is the concept of reduction. So what we have to do is as follows. We have to give this reduction as we said, which means that for some x belongs to L, we have to find a way to map that fx such that fx belongs to click. This is in this case CNF SAT, and fx belonging to click both have the same answer. That is, if this is true, this should be true, and if this is false, this should be false, right? And this fx should be computable in polynomial time, that is order of x raised to c time, where c is a constant. That is what we want to do. In other words, we want to convert this formula into a graph, and embedded in that we should be having the notion of the component k and so on, such that these conditions will be satisfied. So how do we go about doing that is what we will just see. So let us take it that